Good day, folks. This is the Newton's second law application. This is the second question in paper one. Okay, guys, let's cut the chase. Now, the statement, it says two objects A and B of 8 kg and 4 kg respectively are in contact. If you look at this object, this is for 8 kg and 4 kg, they're in contact. Now lies on a plane inclined at 30 degrees to the horizontal. Force F, there's a force that is acted, is applied parallel to the incline, pushes an object as shown in the diagram below. Right, now before we go to 2.1, let's analyze this. The two objects, guys, A and B, their system, right? They're in contact, which means while they're in contact, they're exerting a force on each other. There's a force of A on B, there's a force of B on A, right? They're exerting a force of on each other. So that force that they exert on each other, the force of AB is equivalent to a force of what? B on A, but in opposite direction, and that's Newton's third law. That's Newton's third law, right? Now, another thing that is important is to understand the forces that are acting, the other forces that are acting on these objects. So let's look at this. Let's say in an 8 kg object, there's a normal force, there's a gravitational force. Guys, make sure your normal force and gravitational force are perpendicular to the surface. You can't have a normal force like that, it's not perpendicular to the surface, guys. Now, for the benefit of the doubt, to check that they're perpendicular to the surface, here's the surface, they must make the 90 like that. Okay, guys, this is the force diagram. This is not the free body diagram what I'm drawing here. And there's a force applied here. That's the force applied on 8 kg, and then there's a frictional force on 8 kg. Where do I get that? It's written there in that statement. We'll get to that. There's a frictional force of A, and then what else is there? There's an FG parallel. FG parallel is always down the slope. What else is there? And there's a force of B on A. In what direction? In that direction. There's a force of B on A. Object B is exerting force on A. Guys, let's draw the free body diagram of that, even though we are not asked. So the free body diagram of that, it's going to be an inclined like that. There's a normal force, there's a gravitational force, the gravitational force perpendicular. We have what? We have an FK, should be smaller. Let me make my circle bigger. And then we have FG parallel, and then we have the force of B on A, and then we have the frictional force. The frictional force, it will be downwards as well. Okay, I've drawn the frictional force, and then I'll have the force applied. Right, guys, I hope that free body diagram it's clear and it makes sense. All the three forces that are going down is the frictional force, is the FG parallel, and the force of B on A. Then this is the free body diagram of A. Now the free body diagram, okay, let's answer the question, guys. Okay, let's look at the free body diagram of B. The force diagram of B, it's a normal force, gravitational force, perpendicular, and then we have the frictional force in that direction, it's FK, and then we have the FG parallel there, FG parallel, and then we have the force of A on B, the force of A on B, it's a force of A on B, and that's it. Okay, now it says here, guys, I'm not going to dwell on the Newton's second law. Now the statement that says the magnitude of kinetic frictional force acting on A on B of object A is 6.8 newtons, and the frictional force on B, it's a 3.4. So these two objects, they have different frictional force, and since they're on the same surface, they'll have the same coefficient, which is the description. Okay, the description of the surface. Now 2.2 here, 2.2, it says draw the free body diagram of B. Okay, let's do 2.2 here. The free body diagram of B, I resemble the surface there, the incline, and then the object B, I'll represent it by a dot. We have a normal force, we have an FG perpendicular, and then what else do we have? We have a force of what? Of A on B. And then what else do we have? We have a frictional force, kinetic frictional force, and then we have what? We have what else? We have FG parallel, right? Those are the forces that are acting there. Those are the forces that are acting there. Now 2.3, it says calculate the magnitude of F if the system moves up an incline at a constant velocity. What do you need to remember? When something moves at constant velocity, that's Newton's first law. This is Newton's first, and this simply means your acceleration will be 0 there. Now that's what you need to understand. Now it says calculate the magnitude F, which is we are looking for this force. Guys, let me do the 2.3 here at the bottom. 2.3.1. Now by calculating that force there, we need to use the F net is equal to MA, and then guys, what is important here, there are two ways of doing that. Since it's a system, guys, I'll combine both masses. It's 8 plus 4, it will be equal to 12. So if I combine both masses, so it will be one mass with, okay, let me erase it, guys, it looks clumsy and dirty. Okay, so if I combine these two objects, they'll have one FG parallel. So the FG parallel is for the 12 kg, which is 8 plus 4, and they will have two frictional force of A, frictional force of what? Of B. And then there will be this force applied. So we're looking for this force applied. I think that's the easiest, guys. So what are we going to do? And we choose this direction up the slope as what? As positive. So the forces that are acting on the 12 kg, which is it's a combined there, it's going to be what? The positive force applied, because it's going up the slope, minus the frictional force of A, minus the kinetic frictional force of B. And what is the other force? It's the gravitational force, which is the FG parallel. It's going down the slope. It's going down the slope, and equal to what? To mass times acceleration. Right, since it's moving at constant velocity, remember I said the acceleration is going to be 0. So we are looking for that F. What is a kinetic frictional force of A? We are told there it's 6.8, so it's going to be minus 6.8, minus the kinetic frictional force of B, it's 3.4, and FG parallel, remember it's mg sine theta. So it's going to be minus the mass there, it's 12, remember it's 8 plus 4 times 9.8, sine what's the angle there? It's 30 degrees, is equal to our mass, it's 12 times what? 0. The acceleration is 0, so that side it will be 0. So if you punch that in the calculator, the entire thing, this in the calculator, it will give you the answer that is 69. If you punch that 2.3.2, it says calculate the coefficient of kinetic friction B, for B, B, we are given the kinetic frictional force there. The kinetic frictional force of B is 3.4. So we have Fk there. It's 3.4 newtons. And we're looking for mu K there. And let's go to the formula. We'll use this formula that says Fk is equal to mu K times normal force. And then we have the 3.4 there, and we are looking for mu K and the normal force there. You should remember the normal force is equivalent to the what? To the Fg perpendicular, which is Fg perpendicular is equal to mg cos theta. So the normal force is equal to Fg perpendicular there. So it's going to be what? The mass B, which is it's 4 kg times 9.8. I'm gonna close the bracket. It's not sine. It's cos. It's cos 30. So your answer there, when you divide by that, your answer there, when you punch that in the calculator, it's going to be 3.4 divided by 4 times 9.8 cos 30. It's going to be 0.10 without units. Now let's look at 2.4. 2.4, it says the angle between an incline and horizontal changes to 35, which is the slope here. It increases, it becomes steeper like that. It becomes 35. So guys, now the question here, it says how will the 2.4.1, it says how will the answer at 4.3.2 be affected? What we were doing in 3.2 when we calculated the coefficient. So this question is asking what's going to happen to the coefficient of kinetic frictional force. So the answer there, 2.4.1, it's remain the same. It will remain the same, guys. The coefficient of kinetic frictional force is the description of the surface. It's independent to the angle, and it depends on the type of material, right? So 2.4.2, it says how will the magnitude of kinetic frictional force of B be affected? Write down increase or decrease or remain the same. Guys, there, what do you need to notice there when they asking about the magnitude of kinetic frictional force there? Guys, before I conclude there, what do you need to understand there? From the formula that says Fk is equal to mu K times normal force, which is the normal force, now it's mg sine, it's perpendicular, so it's going to be cos mg cos theta. Guys, what do you need to first do? You need to put the mu K that you have there, you put the mass for B, the 9.8 cos what? 30, and find the answer. So when you find that answer there, you will see this answer is going to be lesser when you do the same and you put 40. It's going to be lesser. This is going to be lesser than this. This one is going to be bigger, and this one is going to be lesser. No, not 40. Not 40. They increase there to 35. So when you put 35 there, and this one is going to be more. This one is going to be more, this answer that you get here, and this answer is going to be what? Lesser. So this simply means that by increasing an angle, what's going to happen? Your FG perpendicular decreases. So this means that an angle, when there's an increase in angle, your FG perpendicular decreases. Right? So if your FG perpendicular decreases, if your FG perpendicular decreases, therefore your frictional force will what will okay, guys, since the FG perpendicular is equal to the normal force, so that means the normal force as well will decrease. So if the normal force decreases, the FK decreases as well, because the FK is directly proportional to the normal force. So the answer here is what is decrease. It's decrease, and then your explanation is this. But in words, you put it in words. Your angle, since your angle increases, your FG perpendicular decreases, while your normal force also decreases, right? FG perpendicular decreases. I didn't show that. Okay, I did. And then your normal force decreases. So your normal force is directly proportional to FK. So that will make what? A decrease in FK. Okay, all right, that's it in this question. Don't forget to subscribe on my channel, guys, and like my videos and share with your family and friends.